Okay, for today we're going to start our mechanical vibration cause and effect course. And of course, as we mentioned before, that we all know and familiar more or less about mechanical vibration. We get in contact with how to measure the vibration, what the most recommended vibration in reports, and what the function of this vibration, or let's say a condition monitoring. That lead us to very important question, that what exactly the meaning of maintenance, what the maintenance is. What do you think about the maintenance? Maintenance is, as a definition, sum of activities which include some like adjusting, replacement. It's all about sustaining the equipment running in health condition. It's all about this. Whatever the technique or whatever the philosophies you are following in maintenance, but finally we need our equipment running in healthy condition. We don't need to have unplanned maintenance or unplanned shutdown or unplanned outage. Okay, that's why we are maintaining the equipment. So we are focusing on having this maintenance activity in the most perfect way we can ever do. According to that, we have some objectives for maintenance. What do you think about this kind of objectives? What? So, yeah, yeah, yeah. Maintenance is, as we said, that maintenance is sort of activities, whether it's replacement of certain parts, adjustment certain parts, even if you are doing redesign for certain parts, is considering part of the maintenance, as long as you're doing this activity under the umbrella or after the operation. Okay, and for reliability is the probability of keeping the equipment running without failure. Like when we talk about reliability of the equipment is 90%, that means its probability of failure is 10%. That mean we can keep this equipment running without failure 90% for this period, and it's different from period to period. Accountability is how you counting or how you judge about the person who doing this activity, and how you punish him, or how you give him rewards or something like this. Okay, that means so this person is accountable or accounted for this activity. That means he is responsible for this one. So if it done in a good way, that means he did it right, and if he didn't good, that means he didn't right way. Okay, so the maintenance main objective is to maximize production. By maximizing this kind of production, that means you are increasing the profits. But we still have very important part, that we can increase the production, and at the time if you increase the maintenance cost, you don't have any profit, you gain no profit. Then the most concern of our maintenance activity or our maintenance vision is to increase the productivity, reduce the maintenance cost. Then in this case you make gap between them, making the profit from this gap, because maintenance is cost, you are spending more money, but it's necessary, it's very much necessary in order to keep your equipment running and reliable and available. Reduce breakdown and emergency shutdown. Of course, if you have any breakdown, that means you stop the production. If you have any emergency shutdown, that means you are forced to do certain maintenance without planning, without preparing. Planning means preparing. You are prepared for something. You plan for this. You plan for your resources, for your time, for your production, for your everything. You plan for this kind of activity, whether it's shutdown or maintenance. Optimizing resource utilization. What the mean of optimizing resource utilization? What the resources we already have from maintenance point of view? We have, first of all, we have manpower. It's resources. Manpower. And this manpower, of course, its qualification, it depends and different from one to one and from team to team. That's why it's important to, when I'm managing our teams, you are spreading this qualification. Like if you have shifts, make an expert in each shift. Don't make all the expert personnel in one shift and let other shifts with no expert persons. By this way, you guarantee that you have good decision to take in all shifts, whether the condition is good or bad. They can take at least remedy action, solve the problem, or at least can sustain the production running without any interruption. Okay. Improving spare stock control. What that mean? What do you think? Can the maintenance improving spare control? What do you think? There is very important part, like by considering a maintenance, if you're doing like PM or preventive maintenance concept. What that mean? That mean you are doing certain maintenance activities for a certain period of time, right? That mean you need spare parts, you need some different resources, and these resources should be repeated every certain time. That means you need stock from these spare parts, for example. In this way, if you follow this kind of philosophy, let's say, that means you need big stock in your store to cover this PM program, preventive program. But what if you are working on condition-based maintenance? That means you're doing maintenance when the equipment need this kind of maintenance. In this case, do you need this much of spare parts in your stock, or you need less, or you need to depend on the condition? And for this kind of condition gives you early warning that this bearing need to be replaced like 1 month before. In this case, you can provide this spare part from the supplier or from local market or from anywhere early than the planned maintenance activity, which you can do by the warning you get from condition monitoring before. So in this case, you can actually controlling the spare parts stock by reduce or by make it more effective. This is the most powerful expression. When you say the stock is effective, that means you're already stocking what exactly you need in short term. And of course, you need to have like a strategic stock, like for example, for turbine, you may have turbine shaft in your store, but maybe you don't need it, but you have to have it. Okay, just in case, as emergency or as strategic spare part. Then, according to this, we found that maintenance start to evolve from beginning to today, and it got through many stages, starting from fix the equipment when it break, up to right now we're doing artificial intelligence techniques, and we're doing predictive maintenance, any different kind of condition monitoring. All of this kind of advanced techniques it was not available early days, like in this area here. Then it evolved by time, it evolved by evolving the technology day by day, year by year. And according to that, we divide this time to generation. First generation of maintenance, we talk about firefighting. Firefighting, that means you fight the fire when it happens, fix it when it breaks, leave the equipment running until it breaks, then go fix it. That's the first thing. And what do you think? Is this technique is good or bad? First one. Then, as we said, first generation, fixed unit breaks. Second, higher availability, lower cost, long asset life. Third generation, talk about availability, reliability, and cost effectiveness. Talk about safety, whether this equipment safe or not, and what the precaution or procedure we have to take to run it in safe way. And this safety is not about the equipment itself. It's about the whole plant, not only the equipment safety. Better product quality. Start talk about the quality of the product and the effectiveness or the effect of maintenance about this quality. Start to talk about the environment and emission, like in gas turbine, we talk about NOx and SOx, the emissions coming out from this turbine or from this equipment in general. Longer asset life, we start considering the asset life and the cost of this investment, how we use this investment as much as we can with the most effective way. Fourth generation that we already have today is managing the physical and economic risk. Start talk about risk. That's why we're doing risk-based maintenance or risk-based inspection. We make risk assessment when we're doing any job. Any job, we have to do risk assessment. And this risk, any kind of risk on the equipment itself, risk on the plant, risk on the people, risk on the industry, risk on the environment, risk on the business reputation, whether the risk, we consider it. We talk right now about standardization and adapting standard. We need to make everything according to standards. We need to unify the practice, unifying the any uncertainty. Why are we doing this? Why we go to standardization? We go to standardization in order to minimize the human error or the human effect. As long as we all following the same steps, the same standard, we almost doing the same thing. And this standard is already studied and put by an expert in this field. That's why we consider that they do the most studies required to get this standard as most perfect as they can. So the minimum error could happen if you follow this standard. And of course, the standard is the minimum requirement. You can add more, but you can't do less than the standard for all standards in any field. Digitalization and Internet of Things. What that mean? Digitalization start right now to digitizing all of things, like doing simulators. You're now simulating everything before even we start a project. We do all simulators, we study a lot of things, we study even the physical places of equipment, we put it in simulator, we start to study the effect of the equipment, what the effect of this equipment on the other one, what the effect on the equipment on the structure, what we do like this, we do like this. We do a lot of simulation for any project before even we start put anything in this project. Internet of Things, that means we start to turn everything to internet. Then we connect them digitally and we start to monitor not only DCS, but we can even monitor cloudly. You can upload or cloud connect all your devices through the internet. Then you can monitor, you can control, you can do a lot of things through the internet right now, of course. Perspective maintenance. You're doing maintenance not only when it's failed, not only by preventive maintenance, not only even by condition monitoring, but you're doing this prospective maintenance considering root cause analysis, considering risk-based inspection, considering many things in maintenance activity. Stewardship and social responsibility. Of course, you have some social responsibility according to your environment, the society around you, all of this. Defect elimination, like studying the root cause analysis or root cause failure analysis, and making innovation if you need to redesign, if you need any modification in order to improve the effectiveness and your reliability. Okay. Then we have very important question. Is the maintenance is support or main function? What do you think? Mm-hmm. Like if you are working in a company providing maintenance services, in this case maintenance will be the main function. Tools of maintenance, the personnel of maintenance, its main function because it's your core business is maintenance. You are providing maintenance. But in our case here, that we are serving the production, whether this production is producing electricity, producing water, producing oil and gas, but it's still supportive activity, not the main one. That's true. But the important question is, can you sustain without this supportive activity? The answer is no, you can't, of course. Like, for example, if you have a car, what the main function of the car? The main function of the car is moving. What it needs to get moved? Need engine, four wheels, and steering. That's it. Even no chair, if you can drive standing, right? But right now you have many things. You have doors, you have body, you have chair, you have air conditioning, you have steering. This steering, power steering or normal steering. You have a lot of supportive systems. Okay. Then the maintenance in this case is not a luxury; it's mandatory, whether it's main function or not. Okay. Okay. So the maintenance is a support activity, not a main function. Then we have two important things. Maintenance deliver equipment reliability, and operation delivers the process reliability. Finally, we have the process availability. Then the main target of us is to have the process availability, keep it running, keep the production running. This is the main function. And to get this running, we have maintenance, we have operation. We have maintenance reliability, we have operation reliability. Then the process is available all the time. And of course, available and reliable in this case. And when you talk about available, that means we have operation, but reliable, that you can rely on this operation to run as long as you plan or as you expected without failure. As we said before, reliability is probability of having failure in a period of time. Reliability is the probability of running without failure in a period of time. Okay. Then we have here the business success, and this business success will not happen if you don't have operation excellency and operational uptime. Okay. Okay. Once again, when we go to maintenance, starting from the beginning, don't fix it. Don't fix it until it fails, of course. And we start to make some evolving. Like you have reactive maintenance, that you start doing some pre-activity before this, and then we have planned maintenance, which is fixed before it breaks. And the question is how we decide exactly when we make this activity and how we know when exactly the failure happened. And proactive maintenance, that you have certain activities to do in order to improve the availability and reliability of this equipment, like studying the root cause failure analysis and all of these things, and take the required precaution and the required activities in order to prevent this upcoming failure. And finally, we start to think strategic way, that we start to think as strategy system, considering a lot of techniques. By moving from this point to this, to this, to this, we find many kind of techniques we have to follow. Like here for reactive and plant maintenance, we are using CMMS system or implementation EAM, Enterprise Asset Management System, to plan and to manage the maintenance programs. And to get exactly what the proactive activity we require, we need to have the manufacturer recommendation and RBI, total preventive maintenance, spares criticality, RCM, BMO, preventive maintenance optimization. We start using different kind of techniques to get this proactive, from planning to proactive. And considering the strategic, we are looking for life cycle cost. All the life cycle cost of the equipment will be considered, starting from the fixed cost or the asset cost itself up to the running cost, and how much it cost us from first day to the end of the day, to the end of its day, its life. Okay, and all these stages can be monitored through KPIs, key performance indicators. And this KPI, there is lead KPI and there is lag KPI. Leads KPI used to monitor according to the data you already have, to monitor the upcoming behavior of this equipment. And the lag one, that you already monitor what already happened in this equipment, and start to put some strategic action or some strategic steps to prevent it from coming again or from happening once again. By improving maintenance, also we improve the reliability. As long as you improve the equipment, of course, reliability improved as well. And in this case, for reliability, starting from this point, which is don't fix it, do nothing, we found that in reliability, it's also do nothing. You have nothing to do. Just keep it running until it fails. That's it. There is no reliability here. Okay? And then start to make, like, improving a little bit from reactive maintenance, that you are fix it when it fail, right? But try to fix it well, just to keep it running as long as you can. After that, we go to preventive maintenance or planned maintenance. We start to improve the reliability a little bit by having the required maintenance before it fail according to certain plan. So you're doing this maintenance whether the equipment failed or not. You follow program. At certain time, you do this kind of maintenance. And in this case, you're improving the reliability from point of you are doing maintenance without failure. So to prevent the failure itself. And after that, we start to improving the reliability by applying the predictive maintenance. That you start to predict the upcoming failure, which improving the reliability. Yes. Then once again, by talking about reliability and the evolving of reliability, we found it evolve by type of maintenance or type of maintenance thinking. How you think about maintenance. Okay, like for doing nothing, we almost have nothing about reliability. But starting from reactive or breakdown maintenance, start improve a little bit, just try to fix it as better as you can to sustain working after repair for longer time. And then we go to planned or preventive maintenance, start doing certain activity. And this activity based on time. And this time is recommended by the manufacturer itself, the OEM, original equipment manufacturer. Or you can even calculate it from your expectation or from your experience or point of view. Predictive maintenance, that you are fixed before it start to fail, or it's at the early sign of failure, you start to take necessary action. Then you have a very much early warning, just to take what necessary to keep the equipment running, to prepare for the maintenance, whether you need spares or other resources like cranes or special tools, manpower, whatever you need, you can repair it before the failure start or the failure happens. Like in vibration analysis, you get early warning when you have high vibration level, but exactly you don't have failure yet. What that means, you have early warning that you have problem, you have bearing to replace, you have alignment to adjust, you have balancing to balance it. Anything like this, you can arrange for this kind of maintenance before actual failure start to get effect or start take place. And finally, proactive maintenance, that you are considering any kind of failure or any kind of proactive even, or sorry, any predictive failures or any predictive maintenance happen, and take it in your consideration to arrange or to modify the preventive maintenance or the maintenance program to prevent the upcoming or any expected failure could happen in future. And of course, looking for root cause analysis, root cause failure analysis for any kind of failure. And very important question here is to identify the failure. And this kind of failure, when we say this equipment failed, what the mean of failure in this case? What the mean of failure? If we talk about pump, for example, and this pump strainer start to be partially plugged, do you think it's failure or not failure? Partially, huh? Not completely failed, not completely plugged. Partially. Is it failure or not? But in fact, we found that we have two failures. One is function failure, the other called performance failure. What that mean? Function failure, when we have like motor burn, the pump is not working anymore. That's it. Performance failure, like I said, like if you have partially plugged strainer, it could run, but it will not perform, right? But in this case, it will affect on what? On reliability. By applying the maintenance program, can we count it as failure? Like we have motor burn and partial plugged. This partial plug takes like half hour or maximum hour operation maintenance activity. But for burned motor, it takes few days, maybe replace all the motor. Can we take both events at the same way, the same weight even? Can we deal with them the same way, the same weight? Or we can't? The answer is we can. Then we need to define what this failure mean. We consider failure, and also different from company to company, with certain rules. Like, for example, if I say this failure or this stoppage, whether it's function or performance, cost us, it's like more than 10,000 USD, that considered as a failure. Then whatever the problem happened cause us loss more than 10,000 USD, considered as failure. Okay? Or sometimes different from machine to machine according to what? According to criticality. Is this equipment critical or not? And this very, very important question. What the mean of criticality? What do you think? What the mean of criticality? When we say this equipment critical or not, let me ask you more question. What do you think if when this equipment, okay, like if we talk about gas turbine, okay, you have 9 FA gas turbine, and I think you have module like 2 9 FA and 1 HRSG steam turbine, low pressure steam turbine. And what do you think if this gas turbine is critical or not? This criticality can affect the production, the power generation, the human life, the environment, the reputation of the company. What do you think in this case? Is it critical or not? Which is the most critical? Then we have criticality matrix. This matrix give us certain criticality according to all these parameters. And according to this criticality, you start to consider type of maintenance or what the effort you have to put in this equipment in order to keep it running in reliable and available way. Okay, right? Like, for example, if I'm talking about the loop oil pump, which deliver oil to gas turbine, is it critical or not? Of course, it's critical, right? But if this equipment or this pump have redundant one, in this case, this pump considered at the same much of criticality or less criticality? What if you have 4 turbine and exactly you need 3 turbine only in service and the fourth one is redundant? Is it critical or not? And how much criticality? It's different, right? Then there's many factors we are considering in consider that criticality. And according to this criticality, you decide exactly what type of maintenance philosophy you need to apply to this equipment in order to running the equipment in reliable manner or in a reliable way. Okay. Then the important question, what is the reliability? As we mentioned before, that reliability is the probability that an item will perform a required function without failure under a stated condition for a stated period of time. That means you keep running this equipment or this part without failure. How much it takes to fail? Okay, what the probability of running this equipment without failure in this period of time? Often we express it as mean time between failures. Mean time between failures, or reliability coefficient, also called quality over time. Okay, but I want to ask you very important question. What the difference between mean time to failure and mean time between failures? Mean time to failure and mean time between failures. What the difference between them? Okay. Mean time between failure and mean time to failure. Mean time between failure, that means you will restore the equipment once again. Like you get the equipment failed, this time, and this probability of failure. And you found by time the probability of failure increase until it fail, then you make maintenance. Then the probability of failure is go down. And then start running again. The probability increase until it start to fail. Then you make a maintenance, it go down again. And so on. But you found that by time it's increased. So it's normally taking positive slope direction in this way. Then by time, the probability of failure increase as well. Okay? But for mean time to failure, that mean you are not using this part again, like air filter, like oil filter, belt. What happened to belt when it cut or when it worn? What happened? You replace it, you throw it away. So you can't say mean time between failures because it's not the same part, it replaced. You say mean time to failure. Okay? You say mean time to failure. Is it clear? Yes, sure. Let's say when we talk about equipment, let's say bump, bump, and we make alignment for this bump, and we found that the seal or the labrum, some like this, started worn a little bit, and we make some adjustment. And after a while, the worn or the some wear happened again, but we keep adjusting at the same equipment. We don't change it. We didn't change it. Then in this case, we talk about mean time between failure because it's the same equipment. Then we can consider this curve because it's the same equipment. But finally, you found that the probability of failure is increasing. Even after each maintenance, you found that here the probability increase and then go down when you do maintenance, the probability. And then increase once again and go down when you do a maintenance. Up again, and so on. But finally, we found that the probability after a while is very, very high. Why? Because it's lifetime. It's lifetime. At this point, we take decision to replace all these parts. But for all these periods, from here to here, we still doing maintenance on the same part, okay? But for here, mean time to failure, that means the same part start and fail. It replaced like bearing, like belts. But when we talk about shaft, the bump shaft itself, we talk about mean time between failures. That we can make repair for this part. About housing, we can make repair. Okay? Is it clear? For turbine, are you replacing the turbine or like turbine shaft? Are you replacing the shaft or you make repair? You may replace blades, you may replace all of these things. Like for turbine, when we talk about repairing the turbine plates, you have some tables for this repair. You can repair these plates maybe 1, 2, 3 times, but you can't keep repairing forever. At certain time, you need to replace these plates, right? Okay, that's why I'm talking that you can keep repairing, you can keep improving these plates for many times, but after certain time you need to replace. Why? Because the stress is reached to certain level, need replacement. It can't withstand anymore. It can't running anymore. It's very dangerous to run these plates under this reliability level now. We talk about reliability. And you found that GE gives you graph like this showing how many times you can repair the plates, and also depend on what time you spend from overall to overall. Like if you exceed the lifetime of the certain overall, like if you're doing hot gas pulse, you're doing hot gas pulse every 12,000 hour, right? What if you doing this overall, but not 12,000, 15,000? You found this component of the gas turbine exposed to high stress more than design. That makes the probability or the probability of failure is increased as well after exceeding these 12,000 running hours. What if you increase the trips times? When you're counting this time or this overall time, BM time, 12,000 for example, you count the running times plus the equivalent times, the equivalent hours times number of trips and starts, right? You're doing this or what? How you calculate the number of running hours? هم؟ يا شباب. Now you can see the whiteboard. Okay, perfect. Uh, okay. The turbine running hours, when we talk about turbine running hours is the running hours times number of trips times the equivalent, and the difference from turbine to turbine, manufacturer to manufacturer, model to model. Like for trips, the manufacturer told you that it's equivalent one trip equivalent to, for example, 5 hours. 5 hours running. Then you found, for example, also these 10,000 running hours, okay, plus 100 trips. 100 trips times 5 equal 500 running hours plus 10,000 equal 10,500 running hours. Then the running hours right now is 10,500. But the counter show you is the running is 10,000 only. Okay. Why that? Why that? Because he takes in his consideration the stresses, the machine exposed when you trip or start the machine, and translate these stresses as running hours. Then he gives you this guidance to decide exactly when you need to make your overall. This the same concept here, as I told you, that we consider mean time between failure or mean time to failure Every time you do this kind of maintenance, you by operating the machine, the probability of failure increase. What the mean of probability of failure increase? That means the reliability decrease. When the probability of failure increase, that means the reliability is decreased. Then you take decision to make this overall here in this point, and by making this overall, the result is reducing the probability of failure. And still running the equipment once again, the probability of failure increase until you reach the overall time. When you're doing the overall, the probability of failure is going down, decrease. What that mean? That mean you are increasing the reliability of the machine by doing this overall. Okay, why? Because you replace the defective parts, or you replace the exhaust parts, like replace blades, replace bearing, replace pads, whatever you are replacing. You are adjusting, you are measuring the clearances, you are adjusting RTDs, connections, thermocouples, proximity probes, all of this stuff, all this kind of activities you are doing to make sure that the equipment is running reliable. Okay. Then once again start running the machine, then the probability of failure increase by time until you reach the overall running hours. And after a while you found that the probability of failure become very high and the failure repeated. Then you need to take decision whether you are release or not using this machine again and replace it, or you make complete overall for the machine, replacing major parts, like as you get a new one. Like that, what we do in 45,000 or 50,000 hour overall, you make major overall, right? اوكي يا شباب؟ اوكي؟ ايه؟ تمام ولا ايه؟ Are you okay? Then, coming back to some calculation, we found that reliability by the book is this equation. Mean time between failure, 1 over mean time between failures equal this lambda, what we call it failure rate. We call this lambda failure rate. Then the reliability, as we said, is the probability of running the equipment without failure at certain period of time. This T is the certain period of time. That's why we found that reliability at certain time. Okay. Considering here lambda, which is the failure rate, which is 1 over the mean time between failure, then the reliability, as we said, that the probability of running the equipment without failure. Let's take this example. A hydraulic system which supports a machining center has operated 3,600 hours in the last 2 years. 2 years, huh? The planned CMMS system indicate that there were 12 failures during this period. What the reliability of this hydraulic system? If it's required to operate for 20 hours or 400 hours. What do you think the reliability of this system after running this 3,600 hours for 2 years with 12 failure? What do you think the reliability of this system if it's running in 20 hours or 400 hours? Which one will be more reliable or the same? Or reliability in this case will be number or different for the required period of time you need to run this system again? What do you think about that? Mhm. Okay. Uh, what time you have now?